Hey everyone, today we're going to learn about definite integrals in a simple way. A definite integral helps us find the area under curve between 2 points on the x-axis. It's like adding a lot of tiny rectangles under a graph of a function. So we write a definite integral like this: f of x from a to b dx. F of x is the function, which is the curve, and a and b are the lower and upper limits, which are the start and the end on the x-axis, and dx tells us we're summing tiny pieces along the x-axis. So we have here an example of a constant function. Find the area under the function of f of x is equals to x from x is equals to 1 and x is equals to 4. So to find the area, we write the integral of 3 from 1 to 4 dx. We then find its derivative, which is 3x. Since 3 is a constant number, after we find its derivative, we integrate the two x-axis, which is 1 and 4. So 3 times 4 is 12, then 3 times 1 is 3. Then we minus it. 12 minus 3 is equals to 9. So our area is 9. Let's proceed now to example number 2, which is a linear function. The problem is we are finding the area under the line of f of x is equals to x from x is equals to 0 and x is equals to 3. So first, we must find its antiderivative of the x. So integral of x dx is equals to x squared over 2. Then we plug the limits, which are 0 and 3. So we have 3 squared over 2 minus 0 squared over 2 is equals to 9 over 2 or 4.5. So our area is 4.5 or 9 over 2. And now for our last example, we have a quadratic function. So we are finding the area under the curve of f of x is equals to x squared from x is equals to 1 and x is equals to 4. So first, we find the antiderivative of x squared. So we write the integration of x squared dx is equals to x cubed over 3. Then we plug in the upper limit and lower limits, which is 1 and 4. So 4 cubed over 3 minus 1 cubed over 3 is equals to 64 over 3 minus 1 over 3 is equals to 63 over 3 or 21. So our area is 21. And that's it. We have learned the basic of definite integrals in calculus. A quick review of what we have covered. A definite integral helps us find the area under a curve between 2 points on the x-axis, and we use its antiderivative to solve it. And lastly, always remember the formula of integrals, which is f of x from a to b dx is equals to f of b minus f of a. So we practice a constant function, which is a rectangle, and second one is a linear function, which is a straight sloping line. And lastly, a quadratic function, which is a curve graph. So always remember, the more you try, the more confident you'll become. Just always practice. Goodbye and keep up the great work on your calculus journey.